All right, I think that we are just about ready to take the derivative so we can find all of its critical values, relative mins, maxes, and whatnot, increasing and decreasing. Yeah, sounds good. So f of x was equal to the natural log of 4 minus x squared. Okay, we want to find its derivative. Derivative of natural log is u prime over u. Couldn't be easier. So u is 4 minus x squared, so its derivative is a negative 2x. It's going to go on top. And on the bottom, 4 minus x squared. Okay, and then we have critical numbers at where? Let's see. Critical number where the top's equal to 0. That's just going to be 0. And x is equal to 0. And as far as that goes, we found that point before, right? This is 0 comma natural log of 4. And what could possibly happen here? Possible min max. I wonder which one it is. Here, let's look at the graph. No clue. No idea whatsoever. All right. And let's see. Oh, wait. Bottom equal to 0. Bottom equal to 0 is 4 minus x squared is equal to 0. Add the x squared over, take the square root, x is equal to plus or minus 2. We have two more critical numbers, don't we? Nope. These are not critical numbers. Why not? They're not critical numbers because those are our vertical asymptotes, right? You're not going to have a relative minimum or maximum at that on vertical asymptote. All right, so we just have one. Let's go ahead and do the first derivative test, which will also give us intervals over which our function is increasing and decreasing. Pretend that says first. Derivative test. Also pretend that says derivative. Our intervals are not going to be from negative infinity to positive infinity this time, because our domain goes from negative 2 to positive 2. So negative 2 to 0 and from 0 to 2. Need some test values. How about a negative and a positive 1? Since this is the first derivative test, kind of makes sense. So we're going to plug those numbers into the first derivative. And we'll plug it into this form right here. So if I plug in a negative, negative times that negative is going to make it positive up top. And on the bottom, it is a negative 1 being squared. We're only taking 1 away from 4, so it's still positive. Positive divided by positive, positive. So f is increasing. All right, and then at 1. If I stuck in 1, it's negative on the top this time, and I'm still just taking away 1. It's positive, negative divided by positive, it's negative. Function is decreasing, increasing, and then decreasing. We found a relative max at 0 comma natural log of 4, since f prime changes from positive to negative. Let's put some fancy parentheses around that. Fancier. At x is equal to 0. We have a relative maximum. Oh, that's what's happening right there. Okay, I can see it now. Relative maximum. All right, one last bit, I guess, and that's to find the second derivative so we can find some concavity. Do you think we're going to have enough room? I don't. Let's go ahead and add an extra page. Preemptively. All right. Finding its first derivative, no, second derivative. I'll do what I do, copy and pasting. And paste. Doop. All right, when we take the second derivative, we'll have to use the quotient rule, unless you're one of those types that avoids at all costs, brings this bottom up to the top to the negative 1 power, and I have a question for you. Sometimes it's nice, but on this one, no, I don't think so. Anyway, so the derivative of the top is negative 2 times the bottom, 4 minus x squared, minus a negative 2x, so positive 2x, times the derivative of the bottom, negative 2x, I think, over the denominator squared. 4 minus x squared squared. Clean it up. Let's do some distributive property here. I'd have a negative 8, negative 2 times a negative x squared plus 2x squared, and then a minus 4x squared. Ooh, I was really hoping that all that stuff would cancel out. Not completely, but you know, the squareds. They didn't. Okay, so let's see, I've got a negative 8 minus 2x squared. And then for the sake of finding supercritical numbers, let's go ahead and factor the top. We'll factor out a negative 2 from that. So negative 2, I'd have a 4 plus x squared. I think over 4 minus x squared. Oh, man, so close. So close to, yeah. Being completely linear almost? No, I guess not. All right, so supercritical numbers. Once again, denominator, we don't care about that one because we already took those out of the domain. How about the top? Is 4 plus x squared ever equal to 0? Nah, because you'd have to subtract over the 4, and we're not going to square any kind of real number to get a negative. Imaginary, sure, but no, not real, which means, hey, no points of inflection. Okay. This also means like it only has one kind of concavity. It's either concave up or concave down. Which one is it? We'll take a look at the function that's right here. This is a positive number. This is positive, and we're multiplying it times negative 2. So no matter what, f double prime of x is going to be less than 0 for, here, I'm going to do it like this, maybe x in negative 2 to 2. Actually, that's not entirely true, right? Because it's, oh no, it actually is. It's always equal to a negative number, no matter what, in between a negative and a positive 2, which means it's always concave down. You know what? Since we do have the second derivative here, notice that our critical number was 0. If I plug in a 0 here, that's gone. I'd have 4 times a negative 2 is a negative 8 up top, and on the bottom is a positive number. It's negative. Our first derivative is equal to 0. Our second derivative was negative. So f prime of 0 equals 0. F double prime of 0 is negative. This is a second derivative test. And this means it's concave down, and you have a critical number. That is a relative max. I didn't have to do that, of course, because we already knew that. Just putting these pieces back together for you. All right, so I think that we have enough information to graph this thing, increasing from from negative 2 to 0, decreasing from 0 to 2. We have a relative maximum right there at 0. X equals 0, and it is always concave down. I think it's going to look sort of like, and it's symmetric. And look how perfectly symmetric mine is. All right, as we like to do, let's compare it to the one on the slideshow. All right, there's our points, there's our vertical asymptotes, and voila.